about a specific provider. For example, welcome back. Now, in today's video, we are going to explore the documentation references related to the data sources. Now, if you remember in the earlier video, we were exploring various examples related to how data source can fetch certain information about a specific provider. For example, here we were reading information about the DigitalOcean account. Then we were reading information from a local file and so on. So the question that comes is, how do we know what kind of information does a data source can read? For example, let's say that you are using AWS. Now for AWS, what are the information that data source can fetch for us is a big question. And the answer to this is documentation. HashiCorp documentation is quite extensive and it will show you what are the data sources that are available for a specific provider, and each data source allows you to fetch what kind of information from a provider. So generally, whenever you explore documentation associated with any provider, there are two important subsections. One is the resources section, which allows you to actually create resource in a specific provider. And second one is the data source section, which allows you to fetch information of a specific provider. So this kind of categorization here you see resources and data sources is something that you will see for wide variety of providers in HashiCorp. Let's explore this. So from the HashiCorp page, let's take example of three random providers so that we understand the overall structure. We are taking example of AWS, GCP and Azure. Now for the AWS provider, if we explore the documentation, since AWS has so many services here, in fact, let me quickly show you to avoid any sort of confusion. If you see, AWS has many services. So you see, under analytics, there are so many services. Under blockchain, under compute, there are so many services and so on. And these are the services that we are referring to. Let's take example of EC2 service because we have been creating certain virtual machines in AWS. So if you look into EC2, first you have a resources section or resources category. So this resources category, it allows you to create some resources in AWS. After resources, you have a data sources category, which allows you to read some information from the provider. And if you see, let's take an example of say AWS underscore AMI. So within here, this specific resource block of AWS AMI will allow you to create the AMI or a operating system image in AWS. Similarly, in the data sources also, you see you have a data source with the same name, AWS underscore AMI. So if I click this, what it does, it fetches the operating system image ID that is already created in your environment. So one is for creation, second is to read the information of the already created resource in your provider infrastructure. Alright, so I hope with this you understood the difference between resource and data sources here. Let's take few more examples. This time we'll take example of the Azure. Similarly, let's take any sample here. Let's take CDN. So again in CDN, you have a resources section, you have a data sources section. And this is the way in which you can understand what data sources are available for a specific service of a specific provider. And if you open up the data source, you can get information related to what kind of information it can fetch from a specific provider. All right. So depending upon what information you need, you'll have to search the data sources and use them accordingly. Great. So that's the high level overview about the data source documentation. This is the primary information that I wanted to share. Again, whenever you're writing the Terraform code, this learning that we have gained proves to be very important in finding the right data sources for your use case. So with this, we'll conclude today's video. Hi everyone and welcome back. Now in today's video, we are going to explore the overall format in which the data source has been defined and also what are the flexibility that we can add as part of our data source to make it more in tune with the use case that we want to achieve. Now at this stage, we already understand the basic format in which a data source is defined, where you have a data followed by the name of the data source that is available, followed by the local name. So this is what the first pointer states, which says data source is accessed via special kind of a resource known as data resource declared using the data block. So this data block that we see is you can also refer to as a data resource. All right. And what does this specific data source does? it fetches the information about the EC2 instance that is running in your AWS environment, and it will export it to the local name of foo. So whenever you're using outputs or something, you'll have to specify data.aws.instance.foo to fetch the appropriate information about the EC2 instance that is being fetched as part of this block. Now, in a larger scale environment, you need to be very specific. You need very specific form or kind of information about a specific resource in your infrastructure. So in such cases, just by mentioning a single line data source block does not fulfill the use case. You can, if you want, you can add certain type of filters based on the requirement. So this is what we are discussing in the next slide, where within the data source block body, so you have a curly braces here. Between these curly braces, you can also add filters that are the query constraint to filter out very specific resources within your environment. For example, here you have a data of AWS underscore instance. Now, a region can have hundreds of servers running. Now, for which specific server are you trying to find the information for? So, this is where you can add the filter, where here you're saying that I am only looking for the servers which has a tag of team and the value of production. So for today's demo, I have two EC2 instances that are running in the North Virginia region. Now, if we'll quickly look into the tags, let's in fact add a tag of say team. I'll say staging. And for the second EC2 instance, I'll add a tag of team and I'll say production. So from the tags, you can easily understand the use of a specific EC2 instance. All right. We have two EC2 instances here, one of staging environment, second of production environment. So now you have a requirement to fetch information about one of the EC2 instance. So you need wide variety of information like the instance ID, the IP address, and so on. So in order to fetch the information about a specific EC2 instance, we know that the data source block needs to be used. So from the AWS documentation, you can go ahead for EC2 service. We do not need resources block because resources will actually create resource for you. What we want a data sources block. Now we want to fetch some information associated with the EC2 instance. So in such case, little bit of efforts are required from our side to understand the right data source block for our requirement. So you have a data source block of AMI and so on. So there is a data source block of here you see AWS underscore instance. So here you have to always read the description what it says. It says use this data source to get ID of a EC2 instance for use in other resources. Now, what are the information that this data source block will fetch is something that you can find in the attribute here. So it can find all of this information. You see so much information it is fetching for EC2 instance. So these are all the information that it will fetch for a specific EC2 instance. Now, if you look into the example usage, you have a data followed by AWS underscore instance followed by the local name which is foo. Now, in fact, you can try it out. Let's just call it as data source ec2.tf. All right. So you can say data AWS underscore instance followed by the name. Let's just call it as example and I'll save this. In case if you want to specify a very specific region, let's say instead of North Virginia, you want to search for instances in Sydney region. So in such cases, you can specify the provider block as well. Let's say AWS. And within here, you can specify the exact region where you want this data source block to fetch the information from. For today's video, just for simplicity, I'm just specifying US East 1. Now again, this provider block is not required if you have configured your AWS CLI with US East 1 region. Even if you do not specify this, it will work perfectly well. Now I'll save this. Now from my CLI, if I try to do a Terraform apply with auto approve, I wanted to show you few things. Here you see it is trying to read. However, it errored out. And what is the error? It states multiple EC2 instances matched. Use the additional constraints to reduce matches to a single EC2 instance. Now from here we can conclude that this specific data source of AWS underscore instance is only used to fetch all of this information that you see associated with one EC2 instance only at a time. And since we have multiple instances, it is saying that you need to use some kind of constraints like filter or any other constraint that is available so that only one EC2 instance gets matched and the data source will fetch the information associated with that EC2 instance. Now, apart from that, in case if you have say multiple EC2 instances, then there is one more data source block. You see AWS underscore instances. You have AWS underscore instance, AWS underscore instances. If you look into the instances here, it states use this data source to get ID or IPs of Amazon EC2 instances. So this is multiple. So in case if you have multiple instances, this is the block that needs to be used. Now, if you'll see, the attribute reference, it is not finding too much information. It is only fetching certain information like private IP, public IP, and so on. So if I replace this with instances, I'll save this. Let's clear the screen. We'll do a Terraform apply. This time it is working perfectly well. Now, if you look into the Terraform TF state associated with a data source of AWS underscore instances, it has fetched certain information like ID, the private IP, the public IP, very similar to what we had seen in the attribute reference. However, if you are using AWS underscore instance, this can be used only for single EC2, but it fetches a lot of information compared to the AWS underscore instances. So let's go ahead and try this out with filter section here. Now, one of the filters that you see is associated with the tag. Now, if you had noticed, we had added a tag where there was a key. You see, there is a key and there is a value. And this is what this filter allows us to match an instance here. So I'll copy this. Let's change this to instance again. And this time within this block, I'll add this filter. All right. So within here, the name should be team. and the value should be production. Alright, I'll save this. Let's clear the screen. Let's do a Terraform apply. Our apply is completed. And now if you look into the TF state file, you will have a lot of information. You see, this time you have the AMI, ARN, and so much information about the EC2 instance is retrieved for you using the AWS underscore instance block. Alright, so I hope with this you understood the basic format of the data sources where you use this data block to specify the exact data source that you need, and along with that we also learned that there are multiple set of data sources block, and it is very important to read the description associated with each data source and also look into the attribute reference which shows you after data source has completed its reading or fetching of information, what is the information that it will store in the TF state file. So that's a very high level overview, and with this we'll conclude today's video. Hi everyone and welcome back. Now in today's video we are going to take up one of the very important use cases where data source is extensively used, specifically while you are creating a lot of servers using Terraform in production environment, and the use case is to fetch the latest operating system image using the data source. So let's go ahead and understand this with a requirement which states that you are responsible to create a Terraform code that creates a new server using the latest operating system image. Now, which image? In this case, it is Amazon Linux, but it can be Ubuntu, it can be Windows Server and so on. So this is a simple requirement of a Terraform code. Now at this stage, what is the approach that you will take to fulfill the requirement? First is that we want to ensure that the latest operating system image is used for creating the server. So typically the steps that we'll follow is you'll go to the EC2 console, you'll fetch the latest AMI ID, something similar to this. You will add the AMI ID in your Terraform code and you will launch the server. So in fact, let me quickly also show you the workflow. So generally what an individual will do to fetch the AMI ID, you will click on launch an instance, you will select the appropriate operating system. There are so many OS. You have Ubuntu OS, Windows OS, Amazon Linux OS and so on, and associated with each OS you have a specific ID. So you will copy this ID and you will hard code it as part of your Terraform code to launch an instance. So this is how your code will generally look like. For AMI, you will hard code the AMI ID here. However, this creates an issue primarily because this is a hard coded static value. What issue this will create is something that we'll discuss in just a moment here. But note that this is a hard-coded static value. Now generally from production environment, note that as much as possible you should avoid hard coding the static details within your Terraform code. Otherwise sooner or later it will lead to you to repeatedly modify your Terraform code to meet the changing requirements. We are going to discuss what exactly this means. So let's look into one of the challenges associated with the static value, specifically the AMI ID that we were discussing. Now, in many of the use cases, the static value will change depending upon the region. For example, in AWS, AMI IDs are specific to region, and hard-coded AMI ID in your code will only work for a single region. Let's understand this. Let's say that you have Mumbai region, Singapore region, and you have Tokyo region. Now each region will have its own AMI year, for example Ubuntu or Amazon Linux or Windows Server. However, the difference here is that the AMI ID associated with the latest operating system image will differ across the region. So in the Mumbai region, let's say AMI ID is 1234. In the Singapore, it is 5678. In the Tokyo, it is 9012. So even though they are same operating system, which is the latest operating system image, the ID will change. Let me quickly also show you this. For example, in Mumbai region for Amazon Linux, or let's say Ubuntu, alright, let's say the ID of Ubuntu is 18C7. Now, if I change the region to Singapore, if you select Ubuntu, you see it is B7B. So it is completely different. Even though it is the latest image of a specific operating system, the ID changes. So now what will happen is, if you have hard-coded this AMI ID associated with a region, say Mumbai. Now if you want to create a EC2 instance in another region, say Singapore, then what you'll have to do, this specific code will not work. You will have to modify this code, modify this AMI ID of a Singapore region, and then only it will work. So let's do one thing. Let me also show you this practically so there is no room for confusion. Now for today's demo, I have a very simple resource block which creates a EC2 instance. And one of the important part here is you have to define the AMI ID. So let's do one thing. Let's go to the North Virginia region. And let's fetch the latest AMI ID that you see over here associated with Amazon Linux based OS. I'll copy this and I'll hard code it over here. Alright, I'll save the change. Now this specific resource block will create a EC2 instance successfully considering that a EC2 instance is created in North Virginia region. The moment you change the region, this block will fail primarily because the AMI ID will also differ. For an example, let's manually specify a provider of AWS here, and in the region, let's say AP South 1, which is Mumbai region. Alright, let's do a save. Now from my CLI, if I'll quickly do a Terraform plan, at this stage you will not see an error. Alright, you will see plan and it is trying to create a EC2 instance with this AMI ID. Now, as soon as you do a Terraform apply with auto approve, let's verify if this works. Immediately here you see you got an error stating invalid AMI ID not found. Alright, so I hope with this you understood the challenge in adding the hard-coded static value associated with AMI. So instead of static value, you want your code to be much more dynamic so that it can work across multiple regions without you having to modify it. So what you want Terraform to automatically query the latest operating system image from AWS and use that to create the server. So in such case, first Terraform should go ahead and fetch the latest operating system image ID associated with whatever operating system you need, and once it fetches the latest AMI ID from AWS, it uses it to go ahead and create the EC2 instance. So now, if you have this kind of an approach, you don't have to worry about hard coding the AMI ID in your code. Terraform will fetch the latest AMI and it will use it as part of creation of EC2 instance. Now, in order to solve this issue, we need to make use of data sources. So what the flow will look like, you have a AWS provider. First, you'll have to specify the data source block and you have a EC2 resource block. So what data source block will do, it will fetch the latest AMI ID associated with the operating system from AWS for a region. And then this specific AMI ID will be passed on to the EC2 instance resource block, which will go ahead and it will create a new EC2 instance from. So in order to solve the requirement that we were discussing as part of the PPT slide number 1, we need to implement this kind of an architecture. So what we are going to do, we'll keep it on hold as part of this video. In the next video, we'll go ahead and implement it practically so that we understand the overall architecture. So with this, we'll conclude today's video. Hi everyone and welcome back. Now in the earlier video we were looking into the disadvantage of hard coding the AMI ID as part of your resource block. We also looked into the benefits of dynamic configuration where your Terraform can fetch the latest AMI ID from your provider and it can be used as part of the EC2 resource block, and the overall setup can be achieved using the data sources. Now in today's video, we are going to go ahead and look into how this can be implemented so that our overall concept can be much more clear. Now for today's video, we have a file called as demo-ec2.tf. This is a very simple file which creates a EC2 instance for us. I have also committed this file as part of a GitHub repository so that you can use it as a base reference. So now what we want is, instead of hard coding the AMI ID, we want Terraform to fetch the latest AMI ID and our resource block should use that AMI ID for the overall creation. Now we know that in order to fetch some information from a provider block, data sources is one of the right approaches to use. So from the AWS documentation related to the AWS provider, since we are dealing with AMIs, which are nothing but the operating system images through which the virtual machines like EC2 can be created, we are more interested in EC2 service. So within the documentation, let's go to the EC2 here. And within the EC2, you have AWS underscore AMI under resources. This is something that we do not want. What we want? We want the AWS underscore AMI from the data sources. All right. So if you look into the description, it states use this data source to get the ID of registered AMI for the use in other resources. This is what we want. Let me quickly show you on how you can see the AMIs generally from the AWS console as well. So generally from the EC2 console, you have a AMIs option here, and within here, instead of owned by me, you can click on public images, and within the public images also you can set one more filter stating owner alias is equal to Amazon. Alright, so now these are all the images available where Amazon is the owner. Now going back to our data source documentation associated with the AWS AMIs, this is how it looks like: data AWS underscore AMI, whatever name that you want to give, and there are certain filters. Because here also, if you see, we had applied certain filters and constraints, and same you will be able to add it as part of your data source that you have defined. So let's try it out. So I'll say data AWS underscore AMI. You can give local name, let's say my image. And now within this block, you can add some constraints. One of the important constraints here is most recent is equal to true. Now, if you look into the documentation, it states if more than one result is returned based on whatever filters that you have defined, then use the most recent AMI. So this is a useful one. I'll use this and I'll add it here. Second one is the owners. If you remember, we had filtered here using the owner of Amazon. So very similar, you can do it over here. So let's try it out. So in the owners, I'll say Amazon. Perfect. Now the next thing is Amazon is owner of so many images. You have Windows Server, you have Amazon Linux, you have Ubuntu and so on. So which specific operating system are you looking for is the one that you'll have to add as part of your filter. So if you'll see in the filter, you can specify the exact value associated with the AMI that you are looking for. So let's add it here. Now within the values here, let's explore. So this is the Ubuntu image. This is the Amazon Linux 2 image. Generally, you will be also be able to find the details about it in the description. All right. So let's explore few more. So there is one which is AL 2023 AMI. Let's explore that. Let's look into the description. It states Amazon Linux 2023 AMI. And when is the creation date? It is Tuesday, April 2, 2024. Now, if you look into the AMI name has a specific structure like AL 2023-AMI 2023 and so on. So based on a structure, you will be able to define the constraints. So let's do one thing just for simplicity. Instead of Amazon Linux, let's take Ubuntu. Now, if you look into the Ubuntu AMI, let's verify. This is canonical Ubuntu 24 LTS. Now, if you look into the structure, AMI name is Ubuntu, images HUMS is the Ubuntu Jammy 2022.04. So what you can do within the filters, you can say something like, let's copy this. Let's copy this here. I'll add it. And the rest part after hyphen is something you can add a wildcard here. So generally, if you see, the creation date is March 1, 2024. Now, sometimes what happens is the Amazon, they keep on updating the image. So if there are some important patches, they'll update the image where the operating system will remain to be the same, but with newer set of patches. So in such cases, the creation date will change and also the AMI ID. Alright, so what we have done in our data section, first we have specified the owner should be Amazon and the name of the AMI, the value here should be this hyphen star. So this hyphen part which indicates the date. So this is 01 March 2024. Very similar to what we see over here. So this part will change when the next update will happen. And this is the reason why here we have given it as a wildcard. All right. So let's go ahead and we'll save the change. Now, just for simplicity, I just wanted to show you a few things. Let me just manually also specify the provider. I'll say region as US East 1. All right. And I'll save the change. Now from our CLI, let's go ahead and quickly do a Terraform plan. Let's verify if our data source is able to fetch the AMI and that AMI is getting referenced or not. At this stage, here AMI is 1234 primarily because we have hard coded this. So what you can do instead of hard coding this, you can create a reference here to the value associated with this data source. So how you can do it? You can say data dot aws underscore AMI dot my image followed by the AMI ID associated with the attributes of this block. So generally, if you look into the documentation, there should be attribute section, and here you will have to find associated with which attribute key does this data source block provide the AMI ID. So if we go a bit down, let's quickly verify. So little bit of searching is required here. So this is the one that we are interested is ID of the AMI. So this is image underscore ID. So within here you can say image underscore ID. I'll save the change. Now let's clear the screen. Let's do a Terraform plan. And this time you should see that the newer AMI ID is automatically populated here. Now one thing that you will see, in fact let's verify if the AMI ID is same. This is FEC and the AMI ID that we had seen from our console is C30. So let's do one thing. Let's in fact open this up in a new tab. Let's copy the AMI ID here. And in the public images, let's search by this AMI ID. So alright, so this is the AMI that we are getting as part of our Terraform output. Now, if you will see, again, this is Ubuntu image. Now the creation date, here you see, this is April 1, 2024. And the AMI ID that we had seen here, this is March 1, 2024. So this is taking the latest AMI, whatever is available here. Now let's do one thing. Let's change the region. I'll say AP South 1. I'll save the change. Let's do a Terraform plan. Let's see if it is able to detect newer AMI associated with the AP South 1 region. And yes, automatically the newer AMI is being populated. Alright. Now, just for simplicity, to make sure that everything is working, I'll also do a Terraform apply with auto approve to ensure that there are no errors. And suddenly we got an error stating invalid parameter value. The architecture of the specified instance type does not match the architecture ARM64 of the specified AMI. So in fact, let me also quickly show you why we are getting this error. Now within the filter, if you would notice, we have explicitly specified in the value, we had specified ARM64-server. So in such case, not all of the instance types are supported. So for example, whenever you try to launch an instance using the AWS console and you select the Ubuntu AMI ID, alright? In fact, let's copy the AMI ID. Let's go back to the EC2 console. In the AMIs, the public images, I'll search the AMI ID that we just copied. Now, if you explore this AMI ID, the architecture here is x86_64. Along with that, the AMI name is also a little different. It is Ubuntu Images HVM SSD Ubuntu Jammy AMD 64 server followed by the timestamp. So in such case, you can use this AMI. In fact, let's copy till here. Let's replace this. Alright, so now you are using the AMD 64 and not the ARM. I'll save this. So now let's go ahead and verify if our Terraform apply operation works. And great, our apply has been completed successfully. And if you look into the Mumbai region, the instances, you see we have one instance that is successfully launched. Alright, so I hope with this at a high level overview you understood the entire structure on how data sources can be used to fetch the AMI ID based on the filters that you have specified, and the EC2 instance can be created accordingly. So with this we'll conclude today's practical video. Hey everyone and welcome back. Now in today's video we'll be discussing about the debugging aspects in Terraform. Now Terraform has a detailed logs which can be enabled by setting up the tf underscore log environment variable to any value. Now you can set the tf underscore log to one of the log levels that includes trace, it includes debug, it includes info, warn or error to change the verbosity of the logs. So sometimes you will see that things are not working as expected in Terraform, or Terraform binary itself is giving you issues. So in order to look into it in more detail, you need more detailed logs. So that detailed amount of logs can be set with the help of the tf underscore log environment variable. So let's quickly look into it. So for today's demo, we have a very simple file called as ec2-debug.tf. Now, if you look into the file, it is very simple. All you have is a provider block and you have a simple resource block that goes ahead and creates a EC2 instance. So let's go ahead and quickly do a Terraform plan. So remember that till now we have not really enabled debugging. So when you do a Terraform plan, just have a note on the amount of output that is generated. So let's quickly wait for a moment. So if you quickly look into it, so this is the output. So not much in detail is being shown over here. So now let's go ahead and set the tf underscore log environment variable. So I'll say tf underscore log is equal to, let's keep it trace. So this we are running it in a Linux box. Now once you have done that, let's go ahead and run the Terraform plan again. And you see the amount of logs that is being generated is very huge when you compare it with the default one when you do not really have any log enabled. So this is something that will allow you to see in detail on what exactly Terraform is doing, and it will also show you the issues that you might be facing, maybe related to Terraform binary or any other aspect. So if things are not working as expected, or maybe if you might want to file a bug report, this is something is what is expected for you to share. Now, one of the question that comes is that such a big report is been visible on the output of the screen. You can also decide to store it in a specific file. So let's try it out. So I'll say export tf underscore log underscore path, and let's call it as temp terraform crash log. Alright, so once you have done that, if you do a Terraform plan, you will see that all of those big messages, you no longer see it within your screen. So what will happen is all of the trace related messages will directly go to the Terraform crash log file that we have created. So let's verify that. So I'll do a nano temp terraform crash.log, and now you see within a single file you have all the trace and the associated logs. So before we conclude, let's look into some of the important pointers for today's video. First one is that trace is the most verbose and it is the default if tf underscore log is set to something other than the log level name. So among all of these, trace provides the most verbose mode. Second is to persist log output, you can set the tf underscore log underscore path in order to force the log to always be appended to a specific file when the logging is enabled. This is also something that we have already seen. So that's the high level overview about the debugging aspects in Terraform. I hope this video has been informative for you, and I look forward to see you in the next video. Hey everyone and welcome back. Now in today's video we'll be discussing about the Terraform format. Now anyone who is into programming knows the importance of the overall formatting of the code for the readability aspect. Now, if you look into this screenshot, so the code here is a valid code, but things are not arranged in a systematic way so that it is easy to read. So, if you'll see here, you have a equal to, then you have to go a little left. So, the indentation is not the best of what can be achieved here. So what Terraform allows us to do is, with the help of the Terraform fmt command, it rewrites the Terraform configuration file to take care of the overall formatting of your Terraform code. So this can be better explained with this screenshot over here, where you have a before fmt. So this is the code which is before fmt, and after you do a Terraform fmt, if you look into the overall indentation, it is much more better and it is much more easier to read. So this is what the Terraform FMT allows you to do. Now let me quickly show you a quick demo so that this can be better explained. Now I'm in the CLI and currently we have a file for today's demo which is test-fmt.tf. Now if you quickly open this up, this is our sample code, and if you see, the things are not really indented in a proper manner over here. So what we can do is we can run the Terraform fmt command, and that's about it. So here it will show you the file that is being modified. And now if you quickly do a cat on test-fmt over here, you see that there is so much of difference. So here the region was slightly on the right, but here the region, the access key, secret key version are in a proper line, and so is the equal to over here. All the equal to are in the same line. So overall, if you look into the modification, in the resource section, you do not really see any major modification here. The primary modification is within the providers section. However, if you had not configured even the resource section properly, this would also have been modified. So that's the high level overview about the Terraform FMT command. I hope this video has been informative for you, and I look forward to seeing you in the next video. Hey everyone, and welcome back. Now today we'll be discussing about the topic of load order and semantics. Now this is an important topic and it will help you write cleaner code whenever you're writing a Terraform configurations in production. So let's get started. Now Terraform generally loads all the configurations file within the directory specified in the alphabetical order. Now one important part to remember here, the files loaded must end in either .tf or .tf.json to specify the format that is in use. So let's say that you have a folder called as terraform.kplabs. Now inside this folder you have 4 Terraform configurations file. Now whenever you do a Terraform plan, all of these 4 configurations file will be loaded. So it is not like you have to write all your Terraform configuration within a single configuration file. Even if you split it up in different configuration file, it is not an issue at all. So let's quickly look into it, post which we'll be discussing in more detail. So for today's video, I have a folder called as load-order, and within this folder I have one file called as semantics.tf. Now if you look into this file, there are 2 resource blocks. There is one variable block and there is one provider block. Now generally whenever you are testing things or during the tutorial, this seems to be fine because you can quickly reference everything within the single file. However, whenever you are writing production code, it is recommended that you do not put everything within a single file. So even though if you will put everything within a single file, it will work perfectly well, but it will not be a cleaner code because generally in production the codes are little bigger. And if you put everything within a single file, and if there is one issue with the variable, then you'll have to search hundreds of lines to look into the data there. So what happens here in production is that it is recommended that you split the code across multiple configuration files. Let me quickly show you. So the first block that we have here is the provider block. So for here, what you can do is you can create a new file called as provider.tf, and you move this provider block within the provider.tf file. Alright, so now you have one file. Then you have one more block, so this is associated with the variable. So for variable, it is recommended that you go ahead and create a file called as variables.tf and move all the variables over here. Similarly, for the resource block, this seems to be good. However, it is better to have a proper naming convention. So if you'll see over here, we have resource of two different types. One is the IAM user and second is the EC2 instance. So for the production, it is recommended to give a proper name. So let's call it as ec2.tf, and let's move this file over here. And for the remaining file where we have the resource of IAM user, let's go ahead and create one more file called as iam.tf, or you can specify iam.user.tf and move this specific resource block to iam_users.tf. So let's go ahead and remove the contents that are part of semantics. Let's close it. So now let's close all the files. So now if you look into the structure over here, you have ec2.tf, you have iam_user.tf, you have provider.tf, and you have variables.tf. So tomorrow a requirement comes that you have to add one more IAM user. What you do, you can simply open the iam_user.tf and add one more resource block. If there is a requirement of adding one more EC2 instance, you know that all the EC2 instance related resource block are in ec2.tf. So simply you can add one more resource block over here, and that's about it. So just by the names, it is much more easier. So tomorrow if one more team member joins and he has a requirement to add one more IAM user, so he can just by looking into the names, he knows where exactly he has to add his own configuration file. Alright, so this is something more of a tip that you can make use of whenever you are writing the Terraform code in production. Second important thing that I wanted to show you today is about the local name of a resource. So currently here the name of the resource is aws_instance.myec2. Now let's do one thing. Before we proceed further, let's do a Terraform plan to verify if this structure is working well. So let's do a Terraform plan quickly. So currently you see everything is working fine. So even though you have splitted things across multiple files, things seems to be good. Now coming back to the topic of the resource local names, let's do one thing. Let's copy this block 2 times over here. Alright, so we have the same block which is defined 2 times. So will it work or will it not work? Let's try it out. So I'll do a Terraform plan, and immediately you got an error saying that the aws_instance resource named myec2 was already declared. Now it is important part to remember that you have a resource. So this is a resource. Let's quickly write it down. You have a resource of type aws_instance, and this resource has a name of myec2. Alright, so this uniquely identifies this specific resource. So now when you have one more resource block with the same name, then it will not work, because then it is difficult to identify a block uniquely. So whenever you are writing a resource block multiple times, it is important that you give a new name to the resource block. So let's call it as new EC2. And when you do a Terraform plan, now things should work pretty well. Alright, so you see everything is working as expected. Great. So these are the 2 primary learnings that I wanted to share in today's video. I hope this video has been informative for you, and I look forward to see you in the next video. Hey everyone, and welcome back. Now in today's video we'll be discussing about the dynamic block in Terraform. Now let's go ahead and understand this with a typical challenge. Now in many of the use cases while you are writing the Terraform configuration file, there are multiple repeatable nested blocks that needs to be defined. Now this can lead to a long code, and it can also be difficult to manage in a longer time. Now one classic example for this would be the security group. Now generally whenever you have a security group, you define multiple ingress or egress blocks. So ingress is basically the inbound rule that you define in the security group. So currently here you see that there are 2 ingress rules that are defined, one for the port of 9200 and second for the port of 8300. So for a single security group, there are 2 ingress rules that are defined. Now imagine, let's say that there are 40 ports that you have to add. So then you have to essentially create 40 ingress blocks within the security group resource, and that can be a bit of pain. So with the help of dynamic block, what it does is that it allows us to dynamically construct repeatable nested blocks which is supported inside a resource, data, provider as well as the provisional block over here. So what we can do here is that instead of defining multiple ingress block, we create one dynamic block, and we also have a variable which basically contains all the port that needs to be defined, and from that variable we create multiple dynamic blocks over here. So that is the high level overview. So let's quickly jump into practical so that this can be better explained. So for today's video, I have a folder called as dynamic block, and within here I have two files. One is before and second is dynamic block. So currently we are in a file called as before.tf where we were discussing about how a security group, depending upon the number of port, will have multiple nested block over here. So you have the first nested block, the second nested block, the third nested block, and so on. So imagine here that if you have 40 different ingress rules over here, then essentially you need to have 40 different ingress block that you will have to define. And same goes with the egress block, which are basically the outbound rules. And in fact, in the organization that I was working with, we had big security group rules, and the amount of ingress blocks were huge. So this used to be bit of pain during the earlier version of Terraform. So this can be solved with the help of the new dynamic block. Now before we explore the dynamic block, let's quickly do a Terraform plan. And currently you see for a security group there are multiple rules, like for 9500, then second is for the 9200, 8300, 8201 and so on. So as we are discussing, there is a better way in which all of these can be combined together in a single dynamic block. So currently this is the dynamic block. Let's quickly remove out a comment here. Now within the dynamic block, the first thing that has been defined here is the variable. The variable is sg underscore port. The type is list of number, and we also have a default value that contains the list of multiple port values over here. So this is something that is easy to understand. Then we have a resource of AWS security group. The name is dynamic sg, and the interesting part here is this dynamic block. Now the label of the dynamic block here is ingress, and we are making use of for each here. So what would happen is that for each value that is part of the variable sg underscore port, so here as you see we have defined var.sg underscore port. So for each value under this specific list, this dynamic block will be created. Now if you look into this content over here, the content here, so from port is equal to ingress.value, which is basically the value of the number that is defined over here. So basically let me quickly show you it in an easier way. So how this would look like, so you have an ingress block, then within the ingress block you will have these specific contents. Alright, so this is the ingress block. Now for the first iteration, so you have for the first iteration, this value would be 8200. So this is the 8200 value. So that is the first iteration. Now you will have one more iteration because there are multiple entries within the list. Now for the second iteration, you will have one more block that will be generated of ingress, and the value of that block would be 8201 and so on. So this is what is referred as a dynamic block. So these blocks are generated dynamically depending upon the number of values that are part of the list. So I hope at a high level overview you understood what dynamic block means over here. So let's do one thing, let's quickly do a Terraform plan so that we understand this in more detail. And before we do a Terraform plan, let me go ahead and comment out the before.tf over here. Now let's clear the screen and let's do a Terraform plan. Alright, so here you see it is working as expected. So with a single dynamic block, you see how many other blocks are being created based on the port numbers that have been defined within the given list. So I hope you understood what dynamic blocks are. Now, when you're working with dynamic block, you also need to understand the basic of iterators. So the iterator argument, which is the optional argument, sets the name of a temporary variable that represents the current element of a complex value. So if omitted, the name of a variable defaults to the label of the dynamic block, which is ingress in this specific example. So let's quickly understand this. So within the dynamic block, we have ingress.value over here, which is basically the value associated with the current element for the for each that is happening over here. So what you can instead do is you can define an iterator, and the name of the iterator here would be port, and instead of the label of the dynamic block you can change it to the iterator name, which is port.value. So what happens here is that it becomes easier to read. So anyone who is reading your code, if he sees port.value, so from here he can easily identify the type of value that is expected for this specific key. So this becomes much more easier. So that's the benefit of iterator. So let's go ahead and do a Terraform plan. So to quickly verify, we'll do a Terraform plan. And to make sure everything is working as expected, we'll also do a Terraform apply. Let's set it to yes. Great. So a security group resource is created. And if you look from the EC2 console, you have a security group called as dynamic-sc, which contains the list of all the ports that are defined. Now, if you look into the resource of AWS security group from the Terraform documentation, you'll primarily see that there are two types of blocks that can be configured. One is the ingress one and second one is the egress. So ingress basically means inbound rules, egress basically means the outbound rules. Now, whenever you're configuring a dynamic block, the name here becomes very important. So let's also try it out for the outbound rules. However, the name this time that we'll have to provide is the egress over here, and for each would remain the same. Let's go ahead and remove the iterator this time, and in case if you remove the iterator, then you'll have to give the label of the dynamic block, which is egress over here. Alright, so now let's do a Terraform plan yet again. So this time the rules that will be created would basically be the egress rules. So let's go ahead and do a Terraform apply to verify. I'll do a yes. Great. So the resource is modified, and from the AWS console, let's quickly refresh the page. And this time within the outbound rules as well, you see that there are multiple outbound rules and the multiple inbound rules. Great. So I hope at a high level overview you understood the importance of the dynamic block. With this, we'll conclude today's video. I hope this video has been informative for you, and I look forward to see you in the next video.